All right, welcome back, everyone. In this session, we'll dive into our very first key method called FindObject. Before we start working directly on this method, we need to set up a new class file for our main menu page, which will hold the code for locating and interacting with objects on this page. First, let's go to the Explorer area in Visual Studio Code, and here we'll create our file. Go to the Pages folder, right-click on it, and select New File. Name this file mainmenupage.cs. This file will contain all the elements and actions for our main menu. Inside the main menu page, the first thing we need to do is import the required AltTester package. This package provides us with the tools needed to interact with the game's UI element. So at the top of the file, we'll add using AltTester.AltTester.UnitySDK.driver. This will let us access the AltTester driver and other essential tools. Next, we will create our namespace to keep our code organized. Think of a namespace as a folder in code that groups related classes. For this project, our namespace is trashcat_automation.pages. So let's add this line. Inside this namespace, we'll define our class. Now we will define our class main menu page. This class is where we will specify all the elements and actions available on the main menu of the game. Here's how we define it. Type public class main menu page extends base page and curly brackets. The key part here is that main menu page extends base page. What this line means is that our main menu page class inherits from base page. By inheriting from base page, we get to use all the setup that's already been done in base page, like the driver connection to the game. This saves us time because we don't have to set up everything from scratch again in each new page file. Now, let's write the constructor for the main menu page class. In C#, a constructor is a special method that's called when we create an instance of a class. For the main menu page, we will write a constructor that accepts an AltDriver object as a parameter. This way, we can pass a specific driver instance when creating the main menu page, allowing it to interact directly with the app. Here's how we write the constructor public main menu page, AltDriver driver, extends base driver. Let's go through what each part does. Public main menu page, AltDriver driver. This line defines our constructor for main menu page. The constructor is public, so we can access it from other parts of our code. It also accepts a parameter, AltDriver driver, which is our driver instance. And then the next one is extends base driver. This part is key. By adding base driver, we are calling the constructor of the base page class and passing it the same driver. This action links the AltDriver instance to base page. So any setup or properties we have configured in base page become accessible in main menu page too, allowing our page to connect to the app and perform actions directly. Now, first, let's connect the game with AltDesktop so we can find objects and perform the required actions on them. I will start by opening the terminal. First, I will locate the attached device, and then I will use the reverse port forwarding command to connect our Android game with AltDesktop. Now, click on the Inspect button to explore the available objects within the game. This will let us examine the game's elements, see their properties, and choose specific objects we may want to interact with for our automation task. Now, let's explore the game objects. Once the game launches, we will see the first scene, which is the start scene. Our focus here is on inspecting the start button. To inspect this button, I will click on the select object cursor and then click directly on the start button within the game. This action will pull up all the details we need about the start button, its properties, structure, and attributes right here in AltDesktop. Now, let's take a closer look at the structure of this button. The start button is made up of two parts, the button object itself and a text object layered on top. First, we will focus on interacting with the button object. The button object has an assigned name, start button. This makes it simple for us to target it specifically in the code. Using this name, we can write code to locate the object directly by its name, ensuring we are selecting the correct button every time. Here's how the code looks. Open VS Code and type public AltObject start button. Then, inside curly brackets, type get followed by the lambda expression operator, and then driver.findObject by name and start button in double quotes. With this line, we are defining the start button as a property using AltObject. We are setting by name to start button, which instructs AltTester to locate the button by name within the game's object hierarchy. Now, whenever we call start button in our scripts, it will point to this specific button, allowing us to perform any required actions on it, like tapping or verifying its state. Now, let's use a similar approach to find the property of the start text object within the start button using FindObject by text. This start text object contains the text start, so let's go ahead and write the code for the start text object. Type public AltObject start text, then inside curly brackets, type get followed by the lambda expression operator and then driver.findObject by text and start in double quotes. Similarly, this line of code defines a property called start text. We are using AltObject to represent the text element associated with the start button. Inside the curly brackets, we have a getter that uses the driver.findObject method. By using by text, we are telling the driver to look for an object that has the text start. This way, we can easily reference the text on the start button in our scripts, allowing us to interact with it or verify its presence when needed. Next, we are going to add a bit of logic to ensure that our start button and its text are visible on the screen before we attempt any actions. This is important because if these elements aren't available when our test runs, it could lead to errors or unexpected results. So let's write a method called isDisplayed. In this method, this is the method signature, which declares that isDisplayed is a public method that returns a bool value, either true or false. On the next line, we use an if statement to check if both start button and start text exist on the screen. The not equal to null condition verifies that these elements are not empty or missing. If both elements are present, the method will return true. Otherwise, if either start button or start text is missing, the method will return false as the fallback case. All right, let's go ahead and create a method to press the start button. We will call this method pressStart. Here is how to write it. Begin by typing public void pressStart. This is the method signature indicating that pressStart is a public method that doesn't return any value, as shown by the void keyword. Inside the curly braces, type start button.tap and semicolon. This line tells AltTester to simulate a tap action on the start button object. So our pressStart method will tap the start button on the screen when it's called in our test scripts. Now let's save our code. This wraps up our current session. In the next session, we'll focus on writing a test case that sets up the test environment, performs a tap action on the start button, and then verifies that the button's text displays correctly. Stay tuned, and I'll see you in the next session.